I'm Dr. Jagadha, Associate Professor in the Department of Mathematics. Today, the topic what we have selected is definitions and terminology regarding multiple integrals, in which we will discuss in detail about definition of double integrals in Cartesian form, definition of double integrals in polar form, definition of triple integrals in Cartesian form. Next one, definition of triple integrals in polar form. Finally, evaluating area and volume using multiple integrals. So, related to these topics, definitions, how they are defined, what is the terminology which is subject to this field, everything we are going to discuss. So the first one is, what is to get this multiple integral, what is the origin of this multiple integrals, from where we obtained these multiple integrals? That is, definite integral is the basic one. What is definite integral? That is, a definite integral is an integral with lower and upper limits. That is, it has lower and upper limits. If it has, then it is definite. If it doesn't have, then indefinite. This definite integral, the extension only multiple integrals. Then the integration in general, integration which is used for the calculation of areas, volumes and displacement. The definite integral, this is the definite integral, that is integral a to b f of x dx, which is related to only one variable, that is the function f, which is defined in the variable x. The limits, the lower limit a, upper limit is b. Then it is definite integral. From the one variable to, if it is connected to two variables, then it is double integral. If it is more than two variables, if it is 3 or 4, so mostly 2, we have double integral and triple integral. In commonly we will call multiple integrals. So that's what which is written here, that is definite integral, the extension to more than one variable, then it is called double integral or multiple integrals. Now this double integral which is used to integrate, what is the usage of this double integral? That is, which is used to integrate over two-dimensional, that is, in two-dimensional coordinate system. This double integration which is used to evaluate the area. So this definitions and terminology, what are the questions we can expect from this? That is, how we can define definite integral. So the first in this video lecture, what are the definitions which are connected to this topic? First we will discuss, then finally we will go to the questions session. So the definition of definite integral. So we can see y equal to f of x be a function to one variable, which is defined and bounded on a comma b. Let this a comma b, that is a closed interval, we are dividing into n sub-intervals. That is, n sub-intervals between here x0, x1, x2 up to xn are the points are there, such that we are defining in such a way that x0 less than x1 less than x2 so on less than xn. But it is compulsory. The starting is A, the ending is B. Here we can see. In between x0 to xn, but x1 is greater than x0, x2 is greater than x1. In such condition, obeying which is written here. So in general, that is xi minus xi minus 1. Suppose if you are taking I is 1, then x1 minus x0 which is equal to del x1. So this is the condition for I equal to 1, 2, n. Now, so this point, that is x0 to xn, in general we have taken in formula wise xi minus 1 to xi. In between, infinite number of points are there. Any point we can select, that is our choice. That's what it is, arbitrary point. So the point which we are going to select, that is an arbitrary point. We can put it in this format. Summation I equal to 1 to n f of ti del xi. If this sum tends to a finite limit, n tends to infinity. What is the meaning of this n tends to infinity? How which is connected to our double integral? That is, first this part we will complete it. So this del xi tends to 0 for the arbitrary choice ti. Then the limit which is defined to be the definite integral. So we can see here one region which is given. That region, you can notice it here, line which divides the region into two parts. One part, this complete region name is R. Here this region name is R1, that is we divided into two regions. If we divide it into n regions, yeah, we can divide it. More if we divide this, we can R3. Like that, Rn regions are there. In the points also, that we noticed it. Ours is A, B. In between, that is points are there. That is our choice. Any point we can select arbitrary point. So we are going on Rn region is there. If that tends to 0, one particular time it tends to. If it tends to infinity, one particular time, this formula what we have written, xi minus 1, which tends to 0. So this is the region we divided. So again, the diagram which is kept here. Now we can see it. Suppose this is the region R, which is in xy plane. Double integral. So the plane is in 2 dimension. That already we have seen in the first slide itself. So bounded by one or more curves. Now f, which is a function defined in the variables x and y. So at all points of R, let the region capital R be divided into small subregions. This is the area of The region is R. We are divided into subregions R1, R2, R3 up to Rn. So the particular R1, the area is nothing but here the mathematical notation which is given. So del R1 here which is written R2, R3, so on up to Rn, which is connected to the formula xi minus 1. And these regions are not overlapping. Next, the coordinate xi, yi, which is there, that is an arbitrary point within the subregion del Ri. We can consider the sum, that is here f of x1 comma y1, this is the area of the region R1, plus f of x2, that is function which is defined in the variable x2, y2, and the area of R2 mathematically written up to n terms we have written. This n only tends to 0. Then this Ri, the area of Ri also tends to 0. If it tends to infinity goes on, one particular time this area also will become 0, irrespective of the choice of xi or yi. Then the limit which is called the double integral of f of x comma y over the region R, and is denoted by the symbol. We can see it here, the integrals. Two integrals are there over the capital R, which denotes region, and f, which is defined in terms of the variable x comma y dr. So this represents our double integral, and so the double integral R, here this dr, which is replaced by dx dy, that is our plane is xy plane. For that xy plane, the function is f of x comma y, evaluating area for this particular function condition satisfying, for which we are using the double integral. So we can expect the questions from which define double integral. We can write this one. Then what is in the formula to calculate area, what is mathematically which is used? This symbol we can write it. Suppose if n tends to 0, then the maximum of the area calculation, what is the value it reaches? The answer is 0. Like that, small questions which can be asked from this slide. So the next again, the definition of double integral. Now, so far we discussed the definition of double integral in Cartesian form. We discussed it. That is, they are in the two dimensions xy plane. If it is a two-dimension only, but instead of going the coordinate system x and y, we are moving to the system of radius and angle. That is, here f is there, which is defined in terms of r and theta, that is dr d theta. If here r1 and r2 which is there, that is a radius from r1 to r2, and the theta from theta 1 to theta 2. We can see it very well. which represents the polar form of the double integration. This integral is first integrated with respect to r, keeping theta as constant. So first, here the interior integration which we defined it for r. So that is the reason here we integrated with respect to r. The outermost one we allotted for theta. So here we can see it. We have done the integration with respect to theta. Suppose in case this the interior integration, if we define for theta, then it will be interchanged. Anyway, we can do it. But which is defined, the interior integration, that with respect to the integration to be done, which is compulsory. Now, then the resulting expression is integrated with respect to theta, that is the outermost integration. So now we can see it, evaluation of area for the bounded regions. So these multiple integrals which is used to calculate the area of the surface. The region should be bounded. That is, double integral which is in Cartesian coordinate system. The Cartesian coordinate system, this is the formula which is used to find the surface area for which we are using this double integral. So we will call it as this is surface integral also, which is connected to the vector calculus. There, the direction will be there. The same which is connected to the direction. Mutually perpendicular vectors. They are connected to normal vectors. That is surface integrals which plays a role in vector calculus. Now, coming to the point here, we are noticing our dr region which is replaced by dx dy, which is in Cartesian formula, Cartesian coordinate. This is used for bounded region to calculate area. Then double integral, suppose to evaluate the integral, they are in curves, the geometrical figure which we have to evaluate. Suppose which is in square, in a circle, curved. If it is in circle, better to evaluate the integral. If we go under polar coordinates, then the evaluation of integral we will be more comfortable. If we go such problems under Cartesian, then this defined formulas to integrate which will become more complicated, and time also extension will be more. So better the curves related to circle problems, so that defined the formula in polar form formula, if we select, we will be more comfortable. So we can see here, that is the integral. So the interior integral which is defined for r, the radius from where to where. So we have to do the integration. It is compulsory, the interior one with respect to radius. Is there any strictly? Here the formula which is written, the interior one which is defined for radius in terms of function theta. The outermost one defined for theta. So the final integration be allocated for theta? Is there any strict rule while solving the problem? These formulas, the defined formulas in polar form, strictly we have to do it. It's not like that. Even interior displays, even theta can dominate. When theta can dominate the interior one, the outermost can be dominated by radius. Any way we can do it. So now, so the above one, which represents the form of the double integration. So now we can see it, the definition of double integral. This just now what we have discussed it. So this is also we discussed it. That is, we are doing the comparison of it. This is which is in the Cartesian form. This is in the form of polar. So when we are doing the comparison, we can see, we can find the difference. Where the differences are occurring, x is replaced by r, y is replaced by theta, dx dy, which is replaced by dr d theta. Here, suppose if we are allocating the interior one y from, then outermost is x from lower limit to upper limit. Here radius, and this is the way if we do comparison Cartesian form and polar form, the variables playing the role of what? Which positions they are occupying. For that, what is the result we are going to obtain defining these formulas? So the defined formulas to use to apply in the problem while solving, we must know it. The formula comes under whether it is fixed for Cartesian or polar form. That identification doing the defined formulas we have to apply. Yes. If we are solving the problem, that problem, the condition which is given in two-dimensional. So to x, y, the variables are dominating in suppose some question. Then we will select a Cartesian form. And another question is there. There we are finding circle, it is there. So the curve, we will be more comfortable. If specifically if they are given in the question that we are asked to it, Cartesian form evaluate, then we have to do this. If it is not mentioned anything, then the defined formula, if it is a circle, better we will, two formulas are defined. One is for Cartesian, another one is for polar form. If nothing is mentioned in the given question for the solution, which defined formula to be selected? For such cases, the curved one, we will go in polar. Okay, so for what we have discussed Cartesian polar, the definitions are over. The terminology to get these definitions, what all are subject to this field of multiple integrals. That is our double integrals we discussed. Okay, fine. Now, the question, what is our problem, what we are going to solve, suppose in case, which is in Cartesian form, they are asking us to do polar form. So strictly they are telling the Cartesian form, the given condition which is defined. But they are telling using this polar form to do it. Then we can't use it straight away, this formula, it is not possible. Then we have to, this point to be noted very, very carefully. In such cases, we have to some assumptions to convert our Cartesian form to polar form. That is x equal to r cos theta. So we are seeing here. Next, y equal to r sin theta. That is also we are noticing here. Jacobian, which plays a role here. It is we are discussing about a two dimension. There is a double integral we are focusing now. So dou of x comma y divided by dou of r comma theta. So the determinant dou x. So we have taken x. Here we can now say it. X we have taken. We completed this r and theta. So dou x by dou r, dou x by dou theta. So the next one is here y is there. Then dou y by dou r, dou y by dou theta. So we will do it now dou x by dou r. Then partially we have to do a differentiation with respect to r. Here which is there. So dou x by dou r we are going to do. The r, the differentiation is 1. So 1 into cos theta, cos theta. The same one, dou x by dou theta we are going to do it. That is here, what I am circling, the cos theta we are going to do the differentiation. That is cos theta differentiation is, we know it, minus sin theta. So it has become minus sin theta into r minus r sin theta. So we completed dou x by dou r, dou x by dou theta, and we filled in the determinant form. Now we will concentrate dou y by dou r. So here r is, the differentiation is 1. So 1 into sin theta, which is written here. Next, dou y by dou theta. Here the differentiation we are saying sin theta. That is cos theta into r, r cos theta. So all the partial differentiation with respect to r and theta regarding our variables, regarding our coordinate system, that is our Cartesian form system related to our variables x and y, the work we completed, and what is the result we obtained it in the respective places we placed it. Now we have to do the determinant. So now the cross multiplication we have to do it. The cross, what is the result we are going to get? Minus of this cross. So we obtained it, this multiplication r of cos square theta. Already here the multiplication is minus r sin square theta, but already outside the negative symbol which is dominating. So it has become plus sin square. R, which is common, we have taken out. This is the trigonometric identity. We know it very well. Cos square theta plus sin square theta, which is equal to 1. So 1 into r, r. So now, this is the Cartesian form double integral formula. In that particular place, our x, which is replaced by r cos theta, and y which is replaced by r sine theta, this dx dy, the Jacobian, what here is there? That into the dx dy, that is dr d theta. So in the two dimension, the dx dy, to convert it into polar form, r into dr d theta. So from the main formula, double integration, this double integration's main formula, definite integral. So definite integral, the next step, double integral. In the double integral, Cartesian form is there, polar form definition is there. Then now we discussed the Cartesian form defined formula, how to convert it into polar form. This is the definition of that, for which we have taken the help from Jacobian. So now we can see it, this double integral, that is which is in xy plane. So to calculate the area dA. So the interior one, that is we defined for r and as a function of theta. So we are doing, this is the thing, we converted into polar form. That's what how this r we obtained it, which is practically explained. Now f of r comma theta, r dr d theta. So the outermost one, which is allocated for theta. So what is the question we can expect from this particular slide? That is how to calculate area using double integral. Then we can produce this formula. Now, evaluation of double integrals becomes easier by changing. Now, when we are doing the double integral, the integration sometimes, which will be very complicated one, which will, our time extension also will be more. In such cases, in some such situations, we can adopt the order of integration. Then how, which is defined it? To get the easier integration is order of integration. That is, change the order of integration. So we can see it here. To change the order of integration, first, what is the limits which are given? According to that, we will draw the geometrical figure with the given limits. But we are noticing the given limits using, already we discussed the interior one related to curves, we will give more importance. The outermost one, we will push it to constants, that is the related to real values. So the formulas, if you select, we are substituting, then also we are finding the integration is more complicated. Then such situations to evaluate our area, because our double integral, which is used to find the area. Two ways we can evaluate. That is the vertical or horizontal, the strips which are used. So suppose the given the limits conditions, we are seeing according to the, what is the, suppose the problem which is given for us to solve. We selected the double integration formula in a correct way. Whether it is Cartesian, yes, the Cartesian defined formula which is ready. Whether it is polar form, that is also ready. But we are finding the integration is very difficult. The given one is vertical. Then we are finding, suppose if it is horizontal way, if we calculate the area, that is, now suppose if it is there one, here I have drawn one rectangle. This particular area we have to, this is the region bounded, This is the vertical way also we can evaluate. Others, one more. If I want to like this horizontal way also, we can calculate for this bounded regions. Any way we can do it. So the vertical way, if it is difficult, better we will move to horizontal way. If horizontal way, which is very difficult, there is a limits. If we apply, the integration is more complicated, then we will move to vertical. So this change of order also changes the limits of integration. So here we have which a small example, which is actually how these formulas are defined. So here we can notice it, that is f of x comma y, the function which is for here the dimension also which is given dy dx. The interior one we are noticing, that is xa is there. That means which is defined for y equal to x, y equal to a. We have to do compulsory with respect to y, yes, which is kept, which is written here dy. The outermost one is 0 to 1 dx. Now we can see it, the basic concept of to do the integration in a very easy manner purpose, we adopted this order of integration. How it plays a role to our defined formulas. What is the terminology to make our integration more comfortable? Just changing the order. So we can notice it here, the animated the diagram, which is in a two dimension. So we can see the coordinate system x and y, and the origin we named it as O, and the coordinate is 0, 0. We can see the parabola, that is a curve which cuts x-axis. So that is x equal to y square, and a straight line, we can say it from the origin, it moves, the touching the parabola, it moves, that the straight line y equal to x. Thus intersecting point, if you solve these two curves, we will be getting 1 comma 1. And to suppose this bounded region we have to find, which is enclosed, we can use the double integration now, which is in Cartesian form, because x and y, the Cartesian coordinate system which is dominating. So vertical way, two ways we can calculate. Vertical way, we are finding it's the integration towards some function what is given, which is very difficult. So here this vertical strip we are naming as A and B. Now we can say it here. This is how we are going to change these are defined formulas of this double integral, our Cartesian form system, regarding the defined formula, how to make our integration more very easy manner. That we will discuss now. That is here x and y. So we can do the comparison study. This is the way vertically we are calculating. Now we are going to calculate in a horizontal way. So everything is same. We can say it here. So this is also same, here same. And here also straight line. The same straight line here. The name which is given here, y equal to x. This is the intersecting point. Only the difference. This is the way we are finding the area. If we do such way, integration is difficult. So this way we are making, subject to our field, to the defined formula, double integral. So now Here we can see it here, that is x equal to uh, y square, which is given. Here x equal to y, which is given. That is here vertical system. Vertical system means we have to take y equal to x. So here we can see it, y equal to x. This is the parabola upper part. We want it y equal to root x. Here which is written, there is according to this condition which is written here. And x, we can see it, which plays a role 0 to 1. But coming to this one, here is there this horizontal strip. The starting one, we have to write x equal to y square. So this we will write x equal to y square. This we can write it here, x equal to y. And here the y1 is, we can see it here and here, that is 0 to 1. So this is the way we can make it our integration very easy way. So the horizontal strip, the name which is given, A and B. Now, so for what we have discussed, double integrals. Now we will move to triple integral. The triple integral, which is also known as multiple integral, which is an extension of a definite integral of a function of single variable to a function of three variables. That is, from one variable which is connected to two variables, double integral. If it is connected to three variables, triple integral. Both the double integral, triple integral put together, common name is multiple integral. Now the triple integral which is evaluated, this is the form of Cartesian form. So the Cartesian form, our function f, which is defined in such a way, x comma y comma z, and here the dimension we can notice it, dz, dy, dx. So the interior one is dz. So here z1 and z2 which is defined. The middle one is y. So y1, y2. The outermost one is x. So x1, x2. This is the Cartesian form for our triple integral formula, where the limits of z are z1 and z2, which are either constants or functions of x and y. Next, the limits of y and y2, that is this one. It is a function of x. That is, here we can write it y1 equal to, this place we can write y equal to x. Here maybe y equal to 2, anything. That's what, this is the meaning of it. The final one is this one, x equal to some 0 or x equal to some 5. So we can see the x limits are constants. Now, so the triple integral, how, what is the purpose of this triple integral? That is to calculate the volume. So volume integral is the integral to find the volume of a region using multiple integrals. Suppose the volume to find a solid region, then which is given as a formula triple integral dx, dy, dz. That is, which is in Cartesian form. That is x, y, z in the Cartesian coordinate system. Suppose if it is cylindrical coordinates, that is our geometrical figure which is in cylindrical, then polar form to be used. Then triple integral r dr d theta d phi. So from this we can expect a question, how to calculate volume using triple integrals. Now, what are double integrals? So for what we have discussed, complete definitions which are explained in detail regarding multiple integrals, that is double integral and triple integrals. The first one is what are double integrals? That is, which is a multiple integral is a definite integral of a function of more than one variable, that is two variables. The example which is given here, that is a f of x comma y. So only this one is the example. This is for double integral. This is for triple integral, both multiple integrals. So now integrals of a function of two variables over the region in R, that is which region given, that we are denoting as capital R, are called double integrals. So the next question is, what are the types of integrals? There are two types of integrals. One is definite and the next one is indefinite. What are definite integrals? That is, a definite integral is an integral with lower and upper limits. That is integral a to b f of x dx. This a and b which will be in real number system. What are indefinite integrals? That is an integral which is expressed without limits and containing an arbitrary constant. So here we can notice it very well. What is the difference between double and triple integrals? Suppose if this question is asked, then a double integral which is used for integrating over two-dimensional region, whereas a triple integral which is used for integrating over a three-dimensional region. Here xy plane, this is xyz plane. How do you find the area between two curves? Suppose the area under a curve between 2 points, which can be found by doing a definite integral between the 2 points. So to find the area under the curve, suppose a curve which is given y equal to f of x, then integrating y equal to f of x, after doing the integration, then the limits values we have to apply from a to b. What is double integral over a rectangle? That is our geometrical, the shape is rectangle. That shape which is in rectangle, that area we have to evaluate. The word which is not given area, but we are telling the reason is double integral which is used to evaluate area for our bounded region. So the bounded region is our rectangle. Suppose in the question triple integral is there, if the word volume which is not given also, it is understood that volume of a particular region we are evaluating. Now, the double integrals over rectangles, when a function of two variables is integral over a rectangular region. The next question, what is R in polar coordinates? In polar coordinates, a point which is in the plane, in which is determined by its distance. Yes. Now, suppose is the two dimension, the distance which is calculated from the origin. So by its R, it's nothing but radius. From the origin and the polar form, R and the angle that is theta, which is playing a role. So angle in radians between the line from the origin to that particular point. Very simple way, r and theta, they are dominating in polar coordinates. So next, what is a question we can expect? What is z in cylindrical coordinates? In cylindrical coordinate system, a point, suppose P, which is in space, then we know it, which is in space, that we have taken in the third dimension, we have kept it. R and theta z, otherwise we can keep it here pi also. R and theta, they are the polar coordinates of xy plane. 3 dimension more 1 it will be. Suppose if your projection is towards the point which is in space, that is P, and z is directed distance from the xy plane to the point P, that is which is perpendicular to our surface xy plane. Now, what is the relationship between our Cartesian and polar coordinate system? So we can convert our Cartesian coordinate system, that is x comma y, to our polar coordinates r comma theta, for which we are taking x equal to r cos theta, y equal to r sin theta. That practically how we have using the Jacobian, we converted it, that already we discussed in detail. The similar manner, this is the Cartesian coordinate in 3 dimension, that is x, y, z is there, that we are converting into polar form, that is r, theta and pi, for which we are taking x equal to r sin theta cos pi, y equal to r sin theta sin pi, z equal to r cos theta. This is also the same as Jacobian using the Cartesian, which will be converted into polar form, the dimensions dx, dy, dz. Here already we discussed dx, dy, how which is converted into polar form, that is r into dr d theta. Similar manner, here also Jacobian using, we have to do the conversion. Next, what is Cartesian coordinate? That is the xy coordinates of your point. Measure the respective distances from the point to a pair of perpendicular lines in the plane which is called coordinate. That is Cartesian coordinate system. We can see this is a x-axis, this is a y-axis. To measure some points, we can see the respective distance from the point. So from here, what is the distance? From here, what is the distance? And we can see this x-axis, which is perpendicular to our y-axis. Otherwise, y-axis, which is perpendicular to our x-axis, which lies in both the axes, which lies in our xy plane. Then which meet at the origin. We have seen to both the x-axis and y-axis, they meet at the origin, that is 0, 0. So now we will come to a conclusion of our topic, multiple integrals, definitions and terminology. First, we have taken double integrals. From the double integrals, how we obtained from the definite integral. The extension to two variables, double integral. Regarding double integral, which is in Cartesian form, we discussed. That means it has coordinate system regarding xy dimension. Then polar in 2 dimension. The radius and angle is important. Then to evaluate the region, our defined double integral formula, how which is connected, that we have done it. Then If you do the double integration, sometimes the integration will be more complicated. Then to evaluate the area, we are doing the two ways, vertical way or horizontal way. If vertical way, which is difficult, we will move to horizontal way. That is vertical to conversion of horizontal, otherwise horizontal to vertical conversion. So in detail, we discussed about double integral, and one more also we discussed. Suppose the given is Cartesian, to change into polar, we have taken help from Jacobian and determinant we found. Next, we moved to triple integrals. What are the things we discussed regarding double integral? Same triple integral also, Cartesian form, polar form. Here x, y, z. Here radius r theta and one more angle phi which is there. Then in double integral, which is used for to calculate area, that's the same concept only which is used in vector calculus, the double integrals which is used for surface integrals. Then the triple integral which is in 3 dimension, that is to calculate volume we are using. This is also connected to our vector calculus, playing a role volume of a region, to volume integrals which is playing a role, and the triple integral which is used in our Gauss divergence theorems, even double integral which is used in our Green's theorem. So far in complete, we discussed it. Regarding our discussion, what are the questions we can expect with the answers we have explained in detail through this video lecture. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.